Yes.
So today President is Tamás, Hajdu Tamás.
Thanks for coming to this talk. I will speak about the relationship between temperature and sleep duration. And I think that this is an important issue. As you know, sleep is so sleep is essential for humans, and we spend about 1/3 of our life sleeping. It is also important to know that there is ample evidence that shows that insufficient sleep or sleep disturbance leads to negative physical, mental health consequences, and greater anxiety, worse cognitive performance, and so on. That's why there is a lot of research that study the factors that influence the quantity and the quality of sleep. And an important literature shows that environmental factors have an important influence on human sleep, including noise, artificial light, air pollution, and exposure to green spaces. And the effect of temperature is related to this broad topic and field of research. And also in light of climate change, I think that this is an important issue. So the previous studies on this temperature sleep relationship consist mainly of laboratory experiments. These studies had small sample sizes and special experimental situations. For example, they use electric blankets, or respondents had to sleep naked at different room temperatures. So the point is that this makes questionable whether the results can be generalized to a wider population. And what is mostly missing in the literature are large-scale studies in real-world settings. But of course, there are a few exceptions. The first paper analyzed the number of days of insufficient sleep or rest over the past 30 years. And this was measured by a single retrospective question. The second paper use data from sleep tracking wristbands, and they have a large data set, at least regarding the number of daily sleep records. And the third paper studied the effect of temperature on mental health, and the authors only identified sleep as a potential mechanism. So they didn't study the details of this relationship, and so this was a kind of side issue in this paper. But yeah, this is the most similar to my study, as they also used survey data, time use survey data. So these are quality studies and really good publications, but there are some limitations and unanswered questions in the literature. First, the days of insufficient sleep provide evidence about the subjective sleep quality, but that says little about an objective measure of sleep duration. Second, using data collected from users of sleep tracking wristbands is prone to selection bias. So middle-aged men tend to be overrepresented in these types of samples. And users of sleep tracking technologies might be more prone to sleep disorders or sleep-related anxiety. So the point is that it is difficult to generalize these results. And finally, probably most importantly, there are unsolved questions about the potential impact of climate change. So, for example, we do not know too much about the effects of heat waves, even though a major consequence of climate change is a sharp increase in the prolonged exposure to heat. Also, we do not know too much about potential adaptation processes. This kind of analysis needs databases spanning several decades, which is missing in the literature. And finally, the potential heterogeneous impacts are also incompletely explored. So what does my study do? It estimates the effect of ambient temperature or sleep duration and projects the effect of climate change. I also try to address some of the gaps in the literature. I use a large number of time use diaries over a 35-year period, and this database provides an opportunity for an in-depth examination of heterogeneities, change over time, and the impacts of heat waves. Okay, let's look at the datasets I use. The first dataset, there are three major databases, and the first dataset is the 5 waves of the Hungarian time use survey. The first wave was in the 70s, and the last was in 2009 and 10. And so in this survey, in these surveys, during a face-to-face interview, respondents complete a time use diary. So, and in these diaries, they provide information about all their activities for the previous day, and always follow an open diary design, which means that respondents are free to report about their previous day without any constraints. So they can say that I did this from this time to that time, and the interviewer puts this into an activity category. Yeah.
It's just I see that you measure in minutes this sleep duration, while you know, I am a middle-aged man, so I have this wristwatch, and it shows, you know, whether your sleep was deep, whether it was, you know, how many hours, how many minutes you spent basically awake, how many minutes you dreamt. So I'm guessing, I'm just asking whether it's, you know, it's the length of the sleep patterns or the quality of the sleep. So if you measure it in length.
Yeah, this is the duration that we found in this survey. So yeah, the sleep tracking response are much better in terms of sleep quality measures. So yeah.
Could it be that, you know, when you sleep in a warm environment, you sleep longer, but in a less relaxed or less deep sleep is much shorter. So how much it affects your results that you cannot really measure the quality of the sleep?
Yeah. So this study we provide no results on sleep quality. So yeah, that's a limitation. But yeah. But there are a lot of respondents, and the distribution can be estimated in a robust way. So yeah, but yeah, it's an incomplete picture. Yeah. Yeah. So yeah, a large sample. So yeah, compared to the previous studies, sample is at least compared to the laboratory experiments, the sample is large. There are more than 130,000 diaries. And what is important that in 3 days, 3 survey days, each respondent completed 4 diaries, so 1 per person, and in the other 2, the respondents completed only 1 diaries. And the main dependent variable is sleep duration, so it's only 30 minutes, and it includes, this variable includes all sleep and periods during the 24 hours covered by the time use diary. And you can see here the average of the sample, and at first it might seem a little bit large, but actually it is similar to the average sleep duration that is found in other time use survey, for example, in the American time use survey.
And there are people like I am, that they are lying in the bed and kind of asleep, but I do not know how much I sleep because, you know, I couldn't watch the clock a minute before I fell asleep. So I think there should be a systematic measurement that we only observe how much time they spend in the bed, but they do not observe how much they actually sleep.
Yeah.
We do that. I get in when it's heatwave, I am lying in my bed and sleep. But, you know.
Yeah, that's true. And I will speak a little bit about this later. But you're right. But yeah, maybe if you were a respondent in one of these time use survey, you pay more attention to what you do. If you
Do you have any additional evidence on maybe for access to any database that where you can actually connect these the time use surveys, or basically validate your results on numbers represented separately using pre-stretches? So whether these
the point is that the sleep duration is clearly overestimated by this time use surveys, and I will speak about this. So in short, probably the time of wake up is measured more or less correctly, but the time of falling asleep is not observed, but only the time of going to bed. So that's why there's a slightly or larger sleep duration in this kind of surveys than in the sleep tracking studies. Yeah.
We will cover later, but we also consider the exact timing of the sleep, like whether somebody has a nap after lunch or.
I will speak about this. So I will split the observations into the nighttime sleep and daytime sleep and so on. Okay, so the second data set is from the European Climate Assessment and Dataset project. This is a gridded data set that contains daily weather observations for Europe, starting from the 50s. And the grids are approximately 10 kilometers away from each other. And this gridded data was aggregated to the country level. So basically, the averages of the grid points within the administrative boundaries of each country were calculated. So country by data set was created, and this data set contains the mean, maximum, and minimum temperatures, precipitation, and relative humidity. And so I will estimate non-linear temperature effects. So actually, 8 temperature categories were constructed, and the lowest is below -5 degrees Celsius, and the highest category is over 25 degrees. And in the main approach, I studied the effect of daily mean temperature, and actually this the temperature of 25 degrees that threshold for further warning of extreme heat. So these are really hot days, and on these days the average of the maximum temperature is close to 34 degrees. So they are John?
Can you consider somehow the role of air conditioning for
No.
estimating the bias, or do you think it's not?
No, I will not speak of air conditioning, so, yeah, I have no information on air conditioning, at least, in the first few days. Maybe in the last days, there are some information, but, I do not use that.
Just a clarification that I missed it. Is it only Hungarian data or you?
It's Hungary.
Hungarian. So you have a time series.
Not time series, but, yeah, 4 days. Yeah, it's, always sort of time series. But that, no, yeah. Yeah, you could say that it's time series, but,
It's
yeah,
a month.
time series.
Hungary.
Yeah, yeah.
I don't know whether you want to show that there is a relationship between the heat waves and the sleeping, or you want to also interact the size of the parameter, but I think it is important that you may have a very important measure of terror in the basically the densely populated parts of the cities are much warmer than the suburbs, for example, also in Budapest. So when the very densely populated blockhouses, they get much warmer than next to the park or with single houses areas.
Yeah,
Is it that?
yeah, probably the temperature exposure is measured, with a big bias, but, yeah, just a classic measurement level. So, yeah, you could, yeah, extrapolate, yeah. There are cases where the temperature are higher, there are lower, but, we can assume that the relationship, the basic relationship is, true, for all these spaces, yeah. Okay, and, also, so, I also, want to add the effect of heat wave days, so I had to, define them somehow. There are 2 definitions in this study. First, heat wave days are those over 25 degree days that are preceded by at least 2 other hot days. And in the second definition, heat wave days are those hot days that are preceded by at least 4 other hot days. So in the second definition, the fifth and the following consecutive hot days are considered as heat wave days. Okay, and the last data set contains the information on future climate. So I used the latest version of the NASA Earth Exchange Global Data Projections database, which contains the daily temperature projections from technical climate models. And in each climate model makes projections under 4 climate scenarios. The first is a very optimistic one. It assumes a significant reduction in carbon dioxide emission and net zero emission by the 70s. And this scenario is consistent with limiting warming to 2 degrees by the end of the century. There is a worst case scenario which assumes high emissions, high greenhouse gas emissions, and fossil-based development. And there are 2 major scenarios. So we have 24 climate models, 4 climate scenarios, and the temperature projections. And what I do is I calculate the annual number falling into the 8 temperature categories. So falling into these 8 temperature categories for each decade, and I compare this temperature distribution to the temperature distribution observed in a baseline period, also from these data sets. So basically, median model temperature changes are calculated. Quite simple. And let's look at the empirical models. So in the first part of the analysis, sleep duration is regressed on temperature, precipitation, relative humidity, and individual characteristics like gender, age, and so on. I also include day of week and an indicator for public holidays, and county by year by month fixed effects are included. So these fixed effects control for all unobserved location by time-specific factors that influence sleep. So this specification means in an intuitive way and that the temperature effect is derived by comparing the sleep duration on a day with a lower temperature in a given county and month to the sleep duration on another day with a higher temperature in the same county and month. Or in other words, I exploit the temperature variation within county and month to derive the temperature effects. Okay. In the second part of the analysis, I project the effect of climate change. I do this simply by multiplying the temperature coefficients from the previous equation by the projected temperature changes. And what is important maybe that uncertainty in the relationship between temperatures and sleep duration is captured by bootstrapping the beta coefficients. And in the end, I have 4,800 projections for each climate model and decade pair, and these projections are assessed and analyzed. So I will show medians into quartile ranges and we do 95% of the projections.
The time use surveys are how are they distributed throughout the year? So every day has the same probability of being.
They start in January and then in September.
Okay, so
they cover the full year. Or maybe one day is an exception, but basically they cover the full year. Okay, and so let's see the results. This figure summarizes the results of the baseline specification. So what you can see here is that below the reference category, polar temperatures do not influence sleep duration, but warmer temperatures have a negative effect. So especially beyond the 15-20 degree category. The effect of that 20-25 degree day is minus 6.3 minutes, and the effect of that and over 20 degree days minus 12 minutes. And so this pattern suggests that the marginal effect of temperature is increasing. This interpretation is supported by the results of recipe cubic line regression and another regression that I use narrower temperature categories. In both cases, you can see that about 20 degrees Celsius, the temperature sleep relationship is much steeper. So yeah, so that's a basic difference. Yeah.
So I see that the difference was significant, but the average sleep was like 500 minutes. So
yeah, it's
50 minutes less. Does it have a significant health effect, or?
This is This is a significant effect. So
Statistically, but I don't know, health-wise.
Yeah, but so I don't know, it's more than 2% effect. But what you expect is just.
I don't know, if that was like 1 hour, I would say, wow.
Yeah, but that would be.
The question is whether you have independent evidences, medical evidences, if such a measure.
Yeah, I will speak about this.
drop-off,
Yeah, I will speak about this.
safety
Yeah, when I will.
have an effect.
Yeah, I will speak about this. Yeah.
Is it just because the nights are shorter typically than the
Sorry.
okay, within months? So
Yeah.
then,
So yeah. So this is a causal effect of temperature.
all right, okay, so the light is.
No, it's not summer versus winter. And yeah, and okay. I will speak about the robustness test, but first, so I wanted to rule out that some unmeasured seasonality drives the results, so I performed the classification test, and so in this specification, the temperature variables are replaced with temperature measured exactly 1 year later. So the idea is that the current sleep duration should not be influenced temperature in this future. And fortunately, and this is what we see here. So absolutely no effect. And I have a series of robustness tests. So I estimated the effects using maximum minimum temperatures, and we see the same patterns. I also use different fixed effects. I exclude the individual control variables. I use alternative methods of clustering and so on. No differences. And one concept may be that ambient temperature affects participation in the time use survey. So cold or hot days, different participants are available. But I found no such effect. So I used the observable characteristics of the individuals as outcome variables, and I estimated the same models, but no meaningful temperature patterns are seen here, and yeah, and only a few coefficients significant. Okay. In 3 survey ways, I could include individual fit effects. So in this case, the sample size is lower, and the standard errors are higher, but we see similar pattern. So he reduces sleep, and this might be interesting. So I used 4 alternative outcome variables. So these are binary indicators whether the total sleep time for an individual is below 6 hours, between 6 and 8 hours, between 8 and 9 hours, or over 9 hours, and use these for binary variables as outcomes. And what you can see here is that heat reduces the chance of sleeping more than 9 hours, and increases the chance of chances of sleeping less than 6 hours, 6 to 8 hours, and 9 to 6 hours. So I think that this is interesting, and at first you can see this as a positive result, but yeah, you know, we often hear about the negative health effects of too much sleep, but actually no credible scientific evidence support this view. So the point is that reverse causality is just as likely. So it's not the case that sick people or long sleep hours causes health problems, but sick people sleep more than worry. And and that's why the recommendation is that adults should get 7 or more hours of sleep per night, and there is no upper limit. In this specific case, it might be that long sleep hours are some kind of compensations for the lack of sleep in the previous days. and he might disrupt this catch-up sleep or something like that. So it's interesting, but yeah, I do not see it as a very positive result. Okay, and I have a specification that I include sunset time, sunrise time, or daylight, because yeah, really monitor these small differences, but yeah, the results are the same.
The rain, you
Sorry?
have data on the rain.
Yeah, it's control, so precipitation and humidity I control for. Okay. Oh. Okay, and now let's look at the effects of heat waves. But before that, I know that in the next part I will show a little bit simplified model. So we saw that the colder temperature categories have the same effects, so they merge into one category. It's a little bit easier to work with in this way. So yeah, so and then the figures look a little bit better with fewer categories. So here we see that the effect of a heat wave day is stronger than the effect of a regular hot day. So in the specification, the over 25-degree days are split into two categories: heat wave days and non-heat wave days. And what we see here is that the effect of heat wave days are stronger, especially if they are preceded by at least 4 other hot days. So the point is that the longer the heat wave, the greater the effect. And this figure summarizes the results on heterogeneity of the effects. On thermally, you can see that heat reduces sleep much more on weekends and public days compared to work days. And possible explanation for this might be that on work days we have a rigid schedule, so we have to work, go to school. Kids, they take kids in nursery and so on. So there is less room for an external disturbing factor to have an effect.
Isn't it because of the beard?
No,
in a not serious way, if it's hotter, you drink more beer and everything else, you behave differently than you would. And if you drink, you sleep worse.
Because you are.
Yeah, but you drink more beer on a day with a temperature over 25 degrees than on a day with a temperature between 20 and 35 degrees.
Yeah.
Or,
Yeah, if it's hot, you drink.
I am not sure, but yeah, that is a.
No, the beer is harmful.
But it's also the impact of the weather, so it's not about us, it's.
Sure, that's
everything.
that's
Including that.
Yeah,
I get it.
okay.
Maybe you go out, you know.
I see your point, but I'm a little bit skeptic. But yeah, so my explanation is supported by this result. So in this case, I estimated this workday weekend difference for employed as students and for others, mainly pensioners. And we see, yeah, there's a confidence interval here, but you don't see that. I see you perfectly.
Measure this separating employed and students. The beer consumption is correlated.
Yeah.
Yeah, okay, yeah, okay,
But the consultation should be the.
This-
Actually, to go. You can control.
It's correct, as Petty said, that people may go out more often, Israel. And they are sitting in a bar or pub or park or whatever, instead of being at home. And you should be able to observe it.
yeah, but yeah. But it's okay. My interpretation is that employed people and students get up early and go to bed late on work days, and so there is no room for any external factor to disrupt sleep, this small amount of sleep. So, and on weekends they have a less tight schedule, and in contrast, there is no such, no large difference between birthdays and weekends, or the schedule of others in between birthdays and weekends. So but I will think about it more.
But sorry, but actually you can because it's a time use survey, you can look at what people, I mean, what you estimate is that people spend less time in bed, right? So that's basically what you said.
And not a nice interpretation, but
but they must do something else, right? So 15 minutes they must. So that you can look at that.
But they do that, okay, and on policy, you see that older people seem to suffer more when they are exposed to heart punctures compared to the middle-aged and young adults, and this is the case for males also, and but I don't know why that's a interesting result. Okay, there are some further results. For example, the baseline relationship is driven by the effect on night sleep. I don't see any effect of sleep during the day, but in this case, there is also a birthday weekend difference. So if on hot weekend days, people sleep less, slightly less, 5 minutes less on during the day. So this is a significant effect. You don't see the, I don't know why, the confidence interval. And also the main results is driven by the effect on the time of waking up instead of time of going to bed. But as we spoke about it a little bit, in the science survey, we see, although there's a period that is labeled as sleep, but probably the time of sleeping plus the time of trying to fall asleep. So, but actually, this means that the effect of sleep is probably underestimated in this analysis.
If I were you, I would push really hard that because of several measurement errors, the actual effects are much larger than you are estimating, and then this area would back at this story significantly because people still go there, and there should be some reason why they are not staying together so much so long that people that period. But have you checked something like that? Those people who sleep a little amount in all days are affected more by heat waves than other people.
Sorry.
So you can achieve that those people who sleep a little in the winter have a larger effect on heat waves than those people who sleep a little.
Yes, I think the problem is that I have only 4 observations per person.
That's enough in every season. You could check those people who are sleep more than 8 hours, say in January, and how they affect how they are affected by heat waves in December.
But I think that 4 observations per season. It's not enough to see the longer averages. So the usual sleeping hours during the winter and
That would be definitely a random measurement error, which is, you know how does it affects
Yeah, okay, yeah, thanks, yeah, I also think about it. Tamás.
This figure is against my years for just.
Yeah, okay. Yeah, but this is, yeah, okay. Yeah, I see your point, yeah.
Not exactly, because it is divided by early and weekends.
That's true. No, but so if you go to bed at the same time, it's not because you went out that that's weird and when you wake up early.
That's because you drink your day. Yeah. Yeah. And also the usual day weekend difference and yeah, there's a slight effect time of going to bed on weekends. But that's me again. I also checked whether the temperature on the previous days affects sleep duration today or not, but I found no related effect. And yeah, regarding the potential application, it might be interesting that there is no difference between the first three survey waves and the last two waves, so there is no change in the effect over time. Okay, so that was the effect of temperature, and now let's see what does it mean for the effect or in terms of the impact of climate change. So in this figure, you can see the projected impacts under the 4 climate scenarios and for the middle of the century and the end of the century. And concentrating on the impact at the end of the century and the projections, you can see that the projected sleep loss is between -3.7 hours and -12.7 hours per person per year. But you can also see that there is a wide range of projections. So yeah, so there's a lot of uncertainty, and because we saw earlier that there is no difference between the effect of cold and mild temperatures, it's not surprising that around 70–80% of this annual sleep loss occurs between June and September. But these are the averages, and heterogeneities are usually not in these kinds of projections, but it's quite evident that the impact of climate change is unlikely to be evenly distributed in society. Yeah.
I don't really understand what we learned from this. So far, I saw that results are insightful, but here we are making quite strong assumptions that these relations remain.
There are some the underlying assumption is that the relationship between sleep and temperature will be the same in the future as it was in the past. Yeah, but yeah, it's pretty common in the literature, and yeah, you can make further assumptions about the future relationships or how they'll evolve and so on, but yeah, it's just an assumption. So this can be considered as a benchmark. And we saw earlier that there is no change during the years of the sample years. So that's a little bit encouraging. Yeah. So yeah. This is just a benchmark. Yeah. And more. So in the next, I will show you some results where I consider the heterogeneous effects of temperature by age. So in this specification, the age-specific temperature coefficients are used, and it's not surprising that the impact for the older people is much larger than the projected impact for the middle-aged and young adults. So for the 90s and under the worst case scenario, the medium projection is 5 to 10 times larger for the older people. Yeah. Okay. And finally, this is the last result. So in this figure, I compare the baseline projections with the projections that consider the effect of heat wave days, so the effect of heat wave and the future changes in the numbers. And what I find is that the projections consider the heat wave days are much stronger than the baseline projections. Yeah, under the worst case scenario and for the 90s, the 60%, I found 60% larger effects. So yeah. So
per month or
per year. This is per person per year. And so what I found is that he reduces sleep duration, but this might have further consequences on a wide range of outcomes. So previous studies found that heat increases workplace injuries, aggression, decreases cognitive performance and health. So sleep may be one of the channels through which heat works, and actually there is direct evidence of this. So there are studies that estimate the impact of daylight saving time. So you know at the spring transition, the clocks move forward an hour, and this leads to a decrease of 40-70 minutes of sleep. And at the same time, there's an increase in the number of car accidents, workplace injuries, number of infarctions, and decline in general well-being. And and there is another line of research that used the variation in time of natural light across time zones, and these studies found a systematic difference in the usual sleep hours at the two sides of time zone borders. So the point is that where the sun sets later, people sleep less on a regular basis. So there is a regular loss of 8 or 30 minutes sleep per day, and yeah, at the two sides of the time zone border. So this is a permanent sleep loss that occurs every day, and these studies also found effects on health, income, and cognitive performance. So the point is that in light of these results, the sleep loss due to heat and warming climate might have further consequences on health, cognitive performance, and general well-being, and so on. Okay, and just a very quick summary at the end. So the main result of this study is that ambient temperature affects sleep duration. As daily temperature rises about 10 degrees, sleep duration starts to decrease, and the effect of the extremely hot days, minus 12 degrees. And but the effect of the heat wave is much stronger. And it might be interesting for that this means that for the Hungarian adult population, the total sleep loss on a over 25-degree day is 0.8 million hours compared to a little bit cooler day. And yeah, regarding the impact of climate change, it might be interesting or an important implication of this study is that heterogeneous impacts and the effects of heat wave days need to be considered as this significantly influence the projected impacts and provide a more complete picture. So I think it's might be important to look at these heterogeneous effects. So thanks for listening, and if you have any questions, we'd like to ask them.
So if I understood correctly, so the effects are driven by the long sleep duration. And also the long duration of
Yeah.
sleep are reduced. The understand that it's not clear that that's good or bad, but isn't it, doesn't it somehow?
Yes, and maybe.
For your conclusions, so sorry.
So
Sorry.
yeah,
I'm not gonna explain.
yeah, maybe yeah, it's one of the main regards. Yeah.
I have a related comment. Maybe you may look for medical evidences, experimental medical evidences, whether the sleep duration may be not independent of the quality of sleep. Maybe the sleep duration is correlated or somehow interrelated with the disturbances of sleep.
Yeah.
And disturbances in sleep may affect strongly the health consequences.
Yeah.
So this affects the conclusion that you conclude.
Yeah, the major limitation of this study is that sleep quality is not measured. And so yeah.
I know, but medical experiments may
Yeah, but,
measure the correlation between the sleep
Yeah, I see.
duration and the quality of sleep.
Yeah,
Maybe they are not independent factors.
So at the beginning, I asked you about, having a nap,
Yeah.
siesta, like, but maybe I missed that.
Yes, so it's yeah, this results. So
Okay.
night sleep is defined as sleep during the night hours, and daytime sleep is defined as sleep during the day. So
But you don't explicitly look for this siesta nap sort of thing.
but how would we define yes or no?
After lunch.
Exactly, so between 12 and
Yeah, that's for, but you know what.
okay, yeah, you could do that, yeah. So, yeah, so the reduces interval and there's
It's a
siesta.
difference whether somebody is sleeping in the morning longer
Okay, yeah,
or having a.
yeah, I see your point, yeah, I could
Yeah,
do that, yeah.
Median southern Europe, typically, they
Yeah.
and system that's.
Yeah,
But so similar to the previous ones, I do think that your main question is what people do instead.
yeah,
That
but yeah. But I think that, yeah, I should look at that, but maybe that's another thing.
no, it I mean, it affects your conclusion. I mean, if for 15 minutes every day, everybody's working and during the weekends and your GDP is going, then it's good.
But still, we see less on because everybody.
Maybe you can control the heterogeneity of temperature, measurement temperature by using the sensor data. You can connect the individual location that the people with settlement at seafood level, and in that way you can get closer to the measurement of the factual air temperature. By using the differences in urban and the rural environments. So this can be a control of that factor that Balázs was projecting.
Yeah. Thanks.
But did you check the loss in sleep time over time? So whether it depends whether it's the first day of the heat wave or the second or the 10th day of the heat wave? Because maybe after a while the human just adapts to that. And what happens after? So if the heat wave ends, do we compensate back?
I checked some delayed effects, but it's I use the two legs, so two effect of temperature on the 2 previous days or 6 days, but I didn't check longer delays. But so there is no compensation within a week that I can say.
But you had the result first, which showed that what you didn't define heat wave, but the daily temperature was about 25 for like 1 to 3 days. You have the regression when you differentiate between the two types of the heat wave and it's not heat wave but very hot.
Yeah.
And for the not heat wave very hot, you also have very significant positive results.
Yeah. Oh, yeah. So, yeah, sorry, but on the
Similar inside.
nothing, yeah.
It's like 11 and 4, so it's.
Yeah, but the longer the heat wave, the stronger the effect.
Interesting.
So the first, there is a prolonged exposure to heat. The first few days, that's a small effect, but that's the effects can stronger.
If there is just the allocation of time, then I will compare the short term to be bigger.
Yeah.
The longer you do, the larger.
Yeah.
With the sensor.
But that's not, but I would expect the opposite, maybe, because on the first day of the interview, so I slept enough in the previous day, so maybe.
But we are more exhausted on the survey. I don't know.
Basically, on the 10th day of the interview, I'm so exhausted from the non-sleep in the previous 9 days that I cannot, I just sleep. Yeah, I know.
Just one more question. You showed that the real effect is working for all people. Can you distinguish people with certain types of diseases? Can you give us the diseases?
Very nice.
Thank you very much. The time is up, so if you have any more questions, then